Welcome into part 2 of the Perfect Media Server video series. Today's topic is hardware, specifically CPUs, motherboards, hard drives, and the other constituent pieces of the puzzle that make up a media server. Now, one of the key tenets of the Perfect Media Server idea is that this whole thing should run on commodity, off-the-shelf, consumer-grade hardware. And whilst that sounds great on paper, trying to pick a single CPU or a single motherboard, a single power supply, or even just a single case might take us a while. You all have different budgets, different spaces, and probably different philosophies on what looks good, what sounds good, that kind of thing. Pricing for components is changing all the time, as well as availability on the used market too. You can't presuppose that that one CPU you find on eBay this week will still be there next week. To add to that, region-specific availability is more complex now than ever, and you might already have a perfectly suitable system somewhere in your life already. Like I said in part 1, Perfect Media Server is not a do things exactly this way type of deal. It's more of a collection of ideas and methodologies that you can apply to thinking when you are designing a system. The perfect in Perfect Media Server really talks about building something that meets your needs perfectly, not some arbitrary standard. That said, what I will do today is talk you through some of the most comprehensive testing I believe has ever been conducted on media server CPUs. We'll also discuss things like what should I look for in a motherboard, how many SATA ports do I need, can I get away with a mini ITX board, do I need an HBA for example? If some of that is gobbledygook to you, don't worry, we'll get into it later in the video. How many PCIe lanes do I need for fast NVMe storage and expansion? What about 10 gig networking? How many hard drives do I actually need? And what about remote access? I know some of you probably just want a shopping list though, so I will link out to a page over at perfectmediaserver.com in the description down below, where I list out my last 2 example Perfect Media Server builds for you. Now this brings us on to the question at hand of just how much system do you actually need? Now, whilst working on this series, it's forced me to challenge my own assumptions about what is really needed for a media server these days. Because when I first got into this stuff, sort of 10, 15 years ago, drives were 1 terabyte, 2 terabytes in size if you were baller, and you really needed a lot of them to get to a usable number of terabytes. But these days, with just a couple of 20 terabyte disks and a fast internet connection, some well-encoded files, you'll probably have more media at your disposal than you can watch in an entire year. Do you really need more than 40 terabytes? Honestly. Okay, so take this into account. This list of TV shows I pulled from my server, for example. Here are the top 26 shows in terms of size. They're sorted by size here. The average size of this 26 show set is 290 gigabytes per show. That's 143 entire TV series at maximum 4K quality. You likely have a wider spread of sizes than this too, to bear in mind as well. Movies is a similar story. I analysed my collection of 766 movies, and on average, they're only about 20 gigabytes each. So 40 terabytes is suddenly enough for 2,000 movies. You will, of course, have different priorities compared to me, but 40 terabytes is really a huge amount of space. And just this weekend, Best Buy listed their famous Easy Store model, the 20 terabyte Western Digital shuckable hard drives, for $279 a pop, which makes a 100 terabyte 5-disc array still the thick end of $1,500, but you end up with 100 terabytes to play with. Now, it's a bit weird to be sat here making a video about building the perfect media server and advocating at the same time for you scaling back your ambitions. But that's the reality of modern hardware. It's insanely powerful, especially for media server needs, which are very modest. And you almost certainly, like most of us do, myself included, are probably planning to completely overbuild this solution. At least in my case, this is based on a series of principles from 10 years ago. Those inputs don't really compute to the same outputs as they did back then. In fact, a friend of mine just moved into an apartment in New York City, and this is his entire home lab media server setup. One Lenovo small form factor 1 litre PC with a 12th gen Intel CPU, and 1 or 2 USB external hard drives. #apartment lab. And with the rise of mini rack builds, now is this a real rise or is this just a YouTuber thumbnail thing, by the way? I know Jeff and Raid Owl and all those guys are jumping on that bandwagon. Is this a real thing? Is this a real trend? Let me know. Perhaps a mini rack makes more sense for your situation. Only you can answer that question. And I did find over the weekend there's r/minilab, the subreddit, and that's growing in popularity too. So if you're curious to know more, I'll put a link to that down in the description. With all that said, let's talk about CPUs though, because they do still matter, and they matter a lot. They're arguably the most important component in your media server. In early 2024, I conducted what I believe is possibly the most comprehensive testing ever done specifically around this media server use case for CPUs. I had help from the community contributing benchmark results over about an 8-month period. Now, I will be doing a dedicated deep dive into the specifics of the testing and the results. In fact, I'll link to a podcast episode from Self-Hosted where I've already done that, and link you to a blog post over at blog.kczme where I've done that too. I just know that video format works well for some people compared to written stuff. Now, that video is coming in the future, but for now, let me walk you through the high-level overview of what we found. First, Intel's QuickSync is a must-have for media servers. It's really that simple. Do not build a media server without it. QuickSync is a hardware encoder built into Intel CPUs that dramatically improves transcoding efficiency. In my testing with the i5-13600K, a fairly modern, powerful CPU, it revealed the stark difference between CPU software encoding and QuickSync hardware encoding. QuickSync completed a 1080p encode in just 14 seconds and used about 10 watts of power continuously whilst doing so. That same file, using CPU-based software encoding, took more than twice as long at 22 seconds and consumed a constant 60 watts of power whilst doing so. Now, I'm reliably told that software encodes do look better, apparently, but compared to the hardware-based encodes, I've only ever really spotted minor artifacts, and if you're a real pixel peeper, you might see a difference, but for the most part, inside our LAN at least, we're going to be direct playing most things anyway. QuickSync is only really useful when you're on the road and probably watching on your phone or some tablet or something where the absolute highest fidelity doesn't really matter. So I play it by these rules. If you're watching it locally, try and direct play wherever possible. If you're on the road, just accept the fact you're probably going to be transcoding it. And in the real world, a fast, energy-efficient hardware transcode is the overall winner in my book. Now, furthermore, the testing revealed that the 7th gen or newer Intel CPUs with integrated graphics, those were the best starting spot for media servers. Now, while there are differences between the generations, and they're less dramatic than you might expect actually, even with the 8th gen i5-8500 from 2018, what's that, 7 years ago, it performs remarkably well against more modern chips for hardware-accelerated encoding tasks. Now, we did see bigger differences for more demanding workloads, such as the 4K HEVC 10-bit content test. The newer chips showed about a 24% uplift over the older ones, but most of us, we're doing 1080p, maybe 4K files. We're not doing HEVC 10-bit content encodes all the time. And the older chips can handle multiple streams of 1080p with relative ease. Now, we also tested the Intel N100 series, a fascinating little chip that sips just 6 watts of power, and that still provides fairly decent hardware encoding capabilities. It managed 139 FPS on our 1080p H.264 test compared to 220 FPS on an i5-9500. Now, it should be said that whilst it was doing that, it was running at half the speed, but it was only using half the power. However, I'd probably still recommend a more powerful chip for most users, since media servers often perform many tasks beyond just transcoding, and the N100 platform is pretty limited in terms of connectivity, with a very limited set of PCIe lanes available. In this graphics card testing, in QuickSync testing, we also tested a dedicated graphics card in the Intel Arc Pro A40. This absolutely demolished everything else in terms of the QuickSync encoders built into CPUs, but it came at a significant power cost. The Arc Pro drew over 65 watts during the test, as well as adding a constant 10 watt load to the system as well. This is in addition to taking up a potentially precious PCIe slot to boot. So what's the bottom line here? For most home users, I think the answer is pretty straightforward. Any Intel CPU from 8th generation onward with an integrated graphics will serve you well. The specific generation that you choose, it will likely come down to a couple of things: current pricing and availability. If you find a screaming deal on an 8th gen chip, go for it. It also depends whether you want newer codec support for things like AV1, because let's not forget, hardware transcoding means that you're locked into the codecs that CPU ships with decoders for from the factory. We should also consider what else you want your media server to be doing beyond serving media, like virtualization, that kind of thing. And then finally, a pretty important thing to consider, power efficiency. My current build uses an i5-13600K, which provides excellent performance with headroom for other workloads. But if you're on a budget, you really can't beat the older 8th, 9th, 10th gen chips on the used market. They still provide great performance for most media server workloads. Now, I want to give a quick shout out to the Intel T-series chips, because a lot of people think that they actually save power in 24/7 applications like a media server. But I don't think that's true. T-series chips show their primary advantage in their advertised lower TDP cap, which basically caps their maximum power consumption under sustained loads. It doesn't affect their idle states whatsoever. Now, this can be beneficial for systems running intensive workloads for extended periods of time, perhaps in a small form factor system where you can't throw a giant CPU cooler at the problem. However, an interesting counterpoint about power efficiency is that under idle load, much faster processors will actually consume far less energy overall because they finish the tasks faster and spend much more time in an idle state. TDP has basically no impact on idle power draw. I suppose it's like that old thing as a kid, like if I run in the rain, do I get wetter, or versus walking, you know? So therefore, it's my conclusion that the T-series chips are a false economy for most people. They often command a price premium from folks thinking that they're getting a more efficient chip, when in actual fact, all they're buying is a chip with less headroom than a non-T variant. And the reality of it is too that many of us will not just simply be serving media from these boxes, we'll use them as a self-hosted, hyper-converged platform to run a ton of apps and maybe dabble with virtualization and other stuff too. And once you have a system running 24 hours a day in your house, it very quickly crosses your mind of, well, what else can I do with this thing? Okay, so that's CPUs. Let's move on to motherboards now. And motherboard choice will ultimately end up being dictated by your CPU choice. But there are a few things to look out for that apply pretty broadly. Now, if you've seen any of my recent videos, you'll know just how important understanding the PCIe lane architecture of your board can be. PCIe lanes are needed for connecting anything to your system, from SSDs to GPUs to network cards, and it can be pretty easy to fill up a consumer motherboard's lanes with a GPU and just a couple of SSDs if you're not planning ahead. Now, I won't get too much into the details here, but you should probably look for something called a block diagram and understand how your motherboard handles something called PCIe switching. So basically, when you put something in slot 1, does it turn off one of the M.2 slots, and so on and so forth? Or does it turn slot 1 from a 16x slot into an 8x slot, and then you get the idea. That will all be covered, for the most part, either online or in your motherboard's manual. It can make a big difference to performance and even affect whether drives show up at all. Now, most boards have a decent layout if you're looking to keep things modest, and most modern boards will happily hook up 4, 5, 6 SATA disks without any problem, a couple of M.2 SSDs, and have space for a GPU if you want to play around with something like local AI or PCIe pass-through, like Linus did over on LTT many years ago now with the 7 Gamers 1 CPU video. Pass-through, though, I warn you, can get pretty advanced pretty quickly, so I won't spin my wheels too much on that topic here. But you can find some good resources over on the Arch Wiki is a great place to get started, and Wendell, of course, the font of all knowledge on YouTube. Wendell's done some great videos on OVMF and PCIe pass-through over the years. Now let's talk about memory. It's likely by this point that your CPU or motherboard will probably be starting to limit the choices you can make elsewhere in your system. The only real consideration that I want you to pay attention to in terms of memory, though, is ECC versus non-ECC or error-correcting memory. Simply put, for us, at home, with media files, ECC does not matter. I know, I can already hear people typing in the comments, but if your platform supports it, the modest extra cost is a no-brainer, but ECC is just not necessary for a media server. Now, in terms of the quantity of RAM, that matters more. 32 gigs should cover most use cases pretty easily. But if you're feeling like you want to future-proof yourself, then 2 32 gig sticks for a total of 64 will last you a very long time. But if the budget's tight right now, buy a single 32 gig stick now and then add another down the road if you feel like you need it. Now, the reason I don't really think ECC is too terribly important is because we're not storing, nuclear secrets on this thing. We're just storing media files. We get the odd bit flip, the odd, thing here or there. Does it matter? Genuinely, does it matter? I mean, you can make that call for yourself, but ECC is typically very useful in highly critical data workload scenarios like ZFS, like huge arrays, that kind of thing. But we're not doing that here. We're just doing a few media files across a few disks. So just keep it simple. Now, add-in cards, if you end up needing more SATA ports than your motherboard can offer, then something like one of these might come in handy. This is an HBA, not to be confused with the cheaper, potentially on the face of it more attractive, simple multi-port SATA cards you can buy on Amazon, but a host bus adapter, or an HBA, is an essential component for a home server build, and it allows you to connect additional SATA or SAS drives to your system. These cards connect via PCIe slots on your motherboard and typically feature SFF 8087 mini SAS connectors. Each of these connectors can support breaking out up to 4 SATA or SAS drives through breakout cables. For optimal performance in NAS systems like ours, HBAs should be flashed to what's called IT mode. This gives your operating system direct access to the physical drives, and in IT mode, the card functions as a simple pass-through device rather than a RAID controller. Don't forget, we're handling the RAID part with MergerFS or ZFS in software, so we don't need a hardware RAID controller. This mode is particularly important for file systems like ZFS that prefer direct drive management. In terms of HBAs that I've had experience with or would recommend, the LSI 9211-8i is widely considered the gold standard and is readily available on eBay for about $70. This is a PCIe 2.0 8X card that supports 8 SATA or SAS drives via 2 of the aforementioned mini SAS breakout cables. Alternatively, the Dell H200 or H310 cards, which are functionally, broadly speaking, identical to the LSI card I previously mentioned, can be often found for under $25 on eBay. This makes them excellent budget options. Now, for those of you building more modern systems, the LSI 9300-8i offers pretty much the same package but with PCI 3.0 support to support SAS 3 or 12 gigs per second speeds, although it comes at a higher price point. Don't forget, when purchasing, you will need to factor in buying a couple of those mini SAS SFF 8087 breakout cables into your budget as well. Now let's talk about power supply considerations. Whilst media servers aren't exceedingly power hungry like a gaming rig might be, here's some guidelines for choosing the right PSU in a 24/7 system. For calculating wattage, most 4 to 6 drive builds are fine with a quality 450 to 550 watt power supply. Remember, each hard drive can pull 25 watts or so during spin up, and cumulatively that adds up. Whilst they're running though, they often idle at around 5 to 6 watts when just sat there spinning. For 8+ drives, aim for 650 watts. If you're going to add a GPU down the road, then obviously you'll need to factor that in as well. Efficiency ratings directly impact your electric bill, and for a 24/7 system, upgrading from a bronze to a gold can reduce your power consumption by roughly 5% or so. In one test case I found online, it saved about 12 watts continuously. However, the law of diminishing returns applies to platinum PSUs because they often carry a significant price premium, and although they carry typically a 10-year warranty versus the cheaper model 3 to 5-year warranties, the modest extra 2% overall improvement in PSU efficiency is unlikely to prove a good return on your investment. For me, the gold rating hits the sweet spot for most people. What about modular versus non-modular? Well, I think the answer really depends on how much you love dealing with cables you're not going to use. For me, go modular. You'll eliminate cable clutter, improve airflow around the drives, critical in smaller cases, and thank yourself later when adding that extra drive without fighting a tangle of unused cables. I've pretty much only ever run Seasonic and EVGA PSUs for the last decade or so and had no real issues to complain of. I am but a humble sample size of one person and about 7 or 8 PSUs though, so take it or leave it, but I have no affiliation to any brands whatsoever mentioned in this video series. This entire series is unsponsored so that I can remain as objective as possible, or as an individual can, and share my unbiased experiences and opinions, really just as a matter of record. Alright, so we've got a bunch of components, but nothing to put them in. So by now, we need to start looking at the case. So you've probably likely created quite a bunch of constraints for yourself by this point. How big of a motherboard did you choose? ITX, micro ATX, ATX? How big of a CPU cooler does your CPU choice need? And how many hard drives are you going to put in it? Am I bothered by how it looks? And am I bothered by how it sounds? What are your particulars around the acoustics of spinning drives? For me, I can't stand to be anywhere near them, which is why all of my spinning drives are sat on a concrete pad in the crawl space in the basement area of this house. Now, there's a page over at perfectmediaserver.com which has been crowdsourced by the community, and it has a bunch of suitable media server cases. The one on the bench in front of me is a now decade-old Lian Li PC Q25B, which it can be a bit hard to find these days, but the thing I like about it is it's got 5 hot swap bays here with a backplane, and I would highly recommend finding a case with a backplane if you can, because I just hate dealing with cables anytime I want to do anything to a drive. Now, some brands to look at these days, Johnsbow do some good stuff. It's pretty hard to go wrong with a fractal defined case if quietness matters to you. Silverstone, they do the CS380 and the 381. They can be a bit hit or miss. But please, if you're watching this and have a strong feeling about a case that isn't already reviewed over at perfectmediaserver.com, submit a review to the site and help your fellow media server enthusiasts by sharing your experiences. Often it's only once you've built in a case you really get to know its quirks. Seriously, please submit your review. Please, please, please do that. One thing from my personal experience, I would highly suggest finding, if you can, are hot swap cages. Rosewill make a pretty decent 4x3.5 inch hard drive hot swap cage that fits in 3 5.25 inch drive bays. I've used them for years and I have not had to fiddle with any cables in that entire time. It's saved me a lot of headaches. Now, I'll give a shout out to Robbie over at NAS Compares, who reviews all of the cases mentioned above and more. Seriously, the guy is a machine. He does so many videos about so much stuff. And there's a really interesting whole new crop of all-in-one NASs coming out of China at the moment that will run any OS that you want. It's well worth checking out his channel and seeing what's coming from some of these up-and-coming brands like AUStar, Minisforum, Ugreen, and so on. It might not make much sense before too much longer to build your own NAS, but for right now, today, there isn't a clear standout winner for me yet. And let's not forget some of the shenanigans that Synology are pulling lately with their drive lock-in stuff. DIY NAS is the way to go. Now, one very important factor we didn't talk about with motherboards was remote access, specifically IP KVM access. Now, a lot of server-grade motherboards charge you an arm and a leg for this functionality, but one huge change over the last few years has been the rise in availability of IP KVMs. It started with the Pi KVM, and then came the Nano KVM, which I happen to have here, followed by the Jet KVM, which I happen to have right here. A quick review on each. Now, there's a Pi KVM in that rack to my side over here. It's fantastic. It's the original. It's extensible, but it's a little pricey if you buy their productized version. The Nano KVM, this little guy, can be a bit buggy, a bit slow, a bit unreliable, but it's tiny and it's cheap, like the budgie. The Jet KVM is probably my favorite overall, though. It's the most promising of the newcomers. It looks a bit like an Apple Watch. You know, it's got a nice little touch screen. It looks really nice. I do wish they'd, rather than on the back, they've put the micro HDMI port for some reason. I don't know why they didn't just put a full-size one, you know, make the device a little bit thicker and put a full-size port. That's beyond me. But the killer feature of this one for me is being able to stream ISOs and boot my system basically from a URL. It's like NetBoot, but I've also got keyboard and mouse access remotely. These little devices are so cool because they can easily zip tie to the back of a case and allow you to control the power, execute commands on the system as if you were sat in front of it from anywhere. And this gets especially next level if you run something like Tailscale on the KVMs and are able to power cycle your system from the other side of the world. Because we've all texted our partners at some point saying, can you just push the power button on the server, please? Yes, I know, we've all been there. These little IP KVMs mean that you can use commodity, off-the-shelf, consumer-grade hardware instead of needing to step up a tier into the workstation or server motherboards, which for us mortals are honestly a bit of a rip-off. They're usually just more expensive without any real-world benefit. Now, you could argue they've probably got thicker PCBs or different, you know, feature sets, but in a lot of cases, they are worse for us because they do silly stuff like ramp fans up and down all the time, because why would anybody run Noctua fans at 600 RPM in a server? Supermicro boards drive me crazy with that stuff. These little guys are awesome and well worth the price of entry. The good news is that with the Pi KVM stuff, despite my proclamation of them being expensive, If you don't buy their productized version, you can just pull a Raspberry Pi out of a drawer, buy, I think it's about $25, $30 camera adapter for an HDMI input into the camera slot on the Pi, and voila, you've got most of the solution with a Raspberry Pi. I'll link to a couple of articles in the description from myself and Techno Tim, talking about how we use one Pi KVM to control multiple systems using an IP switcher as well. It's a whole lot of fun. Now finally, we get to the moment to talk about what's on the bench in front of me. Let's get back to the topic at hand, building a media server. So what do I have on the bench here? Well, I've got here, this was my primary media server when I lived in London several years ago. Its diminutive size and low power draw were really great. It's running a very modest i5-8500 CPU, 32 gigs of DDR4 memory, non-ECC by the way, and an ASRock rack motherboard. It's an ITX size because this case only takes ITX components. In fact, if I take the power supply out, you'll get a better idea of the motherboard that's underneath there. You can see it's running just a standard ATX power supply, although I'd probably recommend going for an SFX power supply in this case. And then it would take up to 5 hard drives here, and then you can mount 2 in the bottom. We'll cover the software side of things next time out, but this is a really tidy little package. But as I've said throughout this entire video, this is not a one-size-fits-all scenario. But given I've had this thing out on the bench for the last 2 videos, I figured I at least owed it to a couple of you to explain what's inside of what you've been looking at this whole time. This is the box that I'll be using throughout this entire series to run all of the software side demos and all that kind of stuff. So now you know. So it's conclusion time, and as we've explored throughout this video, building the perfect media server is less about chasing specs and more about understanding what your actual needs are. We've seen how modern hardware has evolved to the point where even modest systems can handle impressively large media libraries, as I said, with just 2 20TB drives providing enough space for thousands of hours of content. So the key takeaways from the hardware discussion here today are, first, Intel QuickSync is non-negotiable for efficient media transcoding. Any 8th gen or newer Intel CPU with integrated graphics should serve you pretty well as a balance between performance and power consumption. And don't overthink the CPU choice too much beyond ensuring it's 8th gen or newer and has QuickSync. Second, your motherboard selection should provide adequate connectivity whilst understanding the PCIe lane limitations it might have. Most modern boards offer sufficient SATA ports and M.2 slots for a typical media server, but do just verify the block diagram if available so you can plan ahead for future expansions. Third, memory and case choices flow fairly naturally from your other component choices, and 32 gigs of RAM is plenty for most setups. Your case should accommodate your drives count whilst considering thermal management, acoustics, and accessibility. Remember that the perfect in Perfect Media Server is about building something that perfectly meets your needs, not some arbitrary standard that someone else decided. Whether you're using a compact 1-litre PC with external drives or a full tower with hot swap bays or building an entire data center rack's worth of stuff in your basement, what matters is creating a reliable system that stores and serves your media efficiently. And as we've discussed, adding remote management capabilities with an IP KVM solution can transform your experience. It can give you complete control even when you're not physically present and turn that consumer hardware into something that rivals enterprise equipment in terms of functionality. The hardware landscape will continue to evolve, no doubt, but the principles we've discussed today should apply for many years to come and help you guide your choices regardless. Focusing on reliability, efficiency, and building something that fits your actual usage patterns, not just accumulating the maximum number of terabytes possible. So next time out, we'll dive into the software side of things, and this is where the magic really starts to happen, where we're going to start transforming this whole pile of bits into your perfect media server. Get subscribed. There's a link to the Perfect Media Server playlist in the description down below. As always, thank you so much for watching. I've been Alex from KTZ Systems, and I'll see you in part 3.